So in this video, we're going to continue our work in lesson 4.3. But before we do that, a couple of things. Number one, if you don't have a printer to copy off the handout, just use your own paper. And secondly, some of the things we're going to be working on are review from last week, and then we're going to continue into some new materials. So the first problem, if you don't have graph paper, just draw the grids on your own paper. But we've been talking about two different exponential function shapes, depending on the b value. And we've been talking about two different shapes for power functions, depending on the exponent. So if you would go ahead and draw the grids and then draw sketches of each of them. If there are any critical points that are used frequently in drawing these shapes, please identify those points on your graph as well. When you're finished, turn the video back on. So for the first one, the exponential, the key point in both graphs is 0, 1. Generally, the graph goes through 0, 0 from our functions from chapter 3. But with exponential, it's actually at 0, 1. So for the first one is a decay function. So the decay function is coming down, and it's approaching the x-axis, but never touches it if we're looking at the parent function. And then we have the other one goes the other direction. So this one here is referred to as a decay function. This is when the b value is between 0 and 1. And this is an example of a growth function. This is where the b value is more than 1. For the power function, the critical points are usually 0, 0, 1, 1, negative 1, 1. And for one type of function, they're kind of U-shaped, like a parabola, because these are all even functions. As in the exponents are all even numbers. And the critical points here are 0, 0, 1, 1 again, and then the other point is negative 1, negative 1. And these are odds. So the exponents are all odds. Solving equations, we have been solving equations now for about a week. The key here is trying to get the exponent to be a 1. So we've done the first problem here, for example, trying to multiply the exponent 2 by a number to get a 1. And whatever we do to the left side, we're going to do the same thing to the right side. So it's 2 over 1. And we're multiplying it by another fraction to get a fraction that has a value of 1, and that would be 1/2, and that would be 2 over 2. Multiply 2 times 1 in the numerator, 1 times 2 in the denominator. So these are called, we talked about last week, these are called reciprocals. So by doing 1/2 to both sides, the exponent on the x would be 1, and we're doing 149 raised to the 1/2 exponent. Would suggest when putting this into your calculator that when you put in the 149, whatever your exponent key is, it could be a caret, like as I've been using, or it could be like x to the y or y to the x. When you enter it in the exponent, especially if it's a fraction, make sure you enter it in as a division problem and make sure it is in parentheses. Order of operations are extremely important, so without the parentheses, your calculator could give you an incorrect answer. So 149 raised to the 1/2 power, we're going to get approximately 12.207. So like you do, there's 6 problems altogether. So the first one, I kind of went through this kind of reminder of the steps. Trying to get an exponent of 1, that's the exponent we're going to be doing to both sides. And then continue to solve the equation. If there's other things there, such as the 2 on the bottom, we have a subtraction and addition problem. It's like solving equations. We need to get the x to the exponent isolated, so we have to get rid of all the other values first. So there are 3 on this page, and there are 2 on the next page. When you have completed all 5 problems, turn the video back on. Or if you want to just go ahead and do it one problem at a time and listen to the instructional part of it, that's also okay. So when you're finished, turn the video back on. So the next problem, to get an exponent of 1, you multiply the 3 over 1 by, or 1 over 3 by 3 over 1. That would give us 3/3, which is 1. So we're going to x to the first power is equal to 14 cubed. So this answer would be 2,744. In the next problem, again, if you haven't completed, go ahead and turn the video off. But if you're finished with it, in this problem here, you need to get rid of the subtraction of 11 first by creating a value of 0. So we're going to add 11 to both sides, which gives x to the 7th equals 449. To get an exponent of 1, we need to multiply the 7 by 1/7. So the problem becomes x is equal to 449 to the 1/7. So again, as a reminder, 449, your exponent key, put the fraction in parentheses as a division problem. And we get an answer of 2.393. In the next problem, you get the x to the 5th by itself. Subtract 15 from both sides, create a value of 0. So x to the 5th is going to be equal to 175. To get an exponent of 1, we're going to do 1/5, multiply by an exponent 1/5 to both sides, because 5 over 1 times 1/5 will give us 5/5, and that equals 1. So x is equal to 175 to the 1/5 power. So again, 175, your exponent key, 1 divided by 5. So we get an approximate answer of 2.809. On the next page, we've added in a few more elements. We have a multiplication problem, an exponent, and an addition problem. If you think about in terms of order of operations, this generally, not always, but generally, inside of equations, if you reverse the steps of the order of operations, they usually will help you. In this case here, it will. So we're going to reverse the steps. So we're going to get rid of the addition problem first. We're going to get rid of the multiplication problem second. And we're going to do that exponent problem last. So subtract 21 from both sides. We get 5 times x to the 6th power is equal to 740. Then we're going to divide both sides by 5. Create a value of 1. So x to the 6th power is equal to 148. Then again, exponent of 1. We're going to multiply the 6 by an exponent of 1/6. So x is equal to 148 raised to the 1/6 power. And so we get the answer is approximately 2.300. And then the last problem of this set, again, kind of reversing that order of operations. We're going to undo the addition problem, subtraction first, create 0. So negative 2 times x to the 3/5 is equal to a negative 44. Undo the multiplication problem next. I want to do a problem with some negatives in it. So x to the 3/5 is equal to positive 22. To create a value of 1 here, we're going to multiply the 3/5 by an exponent of 5/3. That creates 15/15. You multiply 3 times 5 in the numerator and 5 times 3 in the denominator. And that's going to give me an exponent of 1. So it's 22 to the 5/3 exponent. So the answer will be approximately 172.731. So the next set of problems we're going to be talking about changing rational form into root form. So rational mean or in root form into rational form, so going back and forth. So here we have radicals. And so when changing this into a rational form, we're talking about turning it into something raised to an exponent. So what we're looking for is the number here, the number or variable underneath the radical is being raised to, and the number out here. So in this case, we don't have a number next to x. It's implied to be 1, and it will be 1 throughout our discussion. Whether it's a number or a variable, it's 1. And then on the outside of the radical, if there's no number there, that's always a 2. So this is called square root of x. That's how we read it. And so for square root, we're talking about, like for square, like for square 25, we're talking about 2 identical factors. So 5 times 5 is 25. So here, the reason that's a 2 here is we're looking for 2 identical values that will get us to that answer. When writing the fraction, the number that is next to the value underneath the radical is the numerator, and then our number on the outside is our denominator. So this would be x to the 1/2. You go ahead and look at the other main problems on this screen, and if you would please write each of them as a base to a fractional exponent, and turn the video back on when you're ready. So the second one will be x to the 1/3. There's not a number here, so that's going to be an x to the first. This will be x to the 1/4, x to the 1/5. This would be x to the 2/6, and that gets simplified to x to the 1/3. So sometimes you may find some of these fractions can be simplified. And then this one here is x to the 3/7 and y to the 4/7. I will say that when writing these expressions as rational, in rational form, we generally don't write the exponent like 2 1/3. We'll keep it as 7/3, for example. So try to keep them as fractions unless they can simplify to a nice whole number value. Next page, they're getting a little more complicated, so go ahead and write these in those rational forms, and then turn the video back on when you're ready. So the exponent on the 81 is actually a 1, so this is 81 to the 1/4, x to the 7/4, and y to the 6/4. The y can actually be simplified to y to the 3/2. Divide both numbers by 2. The next one, going to the right, the the number out here is not given, so it's a 2. It's always implied to be 2. So this would be 3 to the 5/2, x to the 4/2, and y to the 7/2. And the exponent on the x, we can simplify it just simply 2. And then the last one of this set, you're going to have 2 to the 9/3, x to the 4/3, and y to the 5/3. And again, the exponent on the 2, we can simplify that to 3. So we're going to go the other direction here. So writing this in radical form, keep in mind that the denominator is the number that goes outside the radical. So the number here would be 3, and then this is